So we're going to talk about factoring today, 4.4. So far, you know of basically three main different methods of factoring. You know GCF, you know AC method, difference of perfect squares. And then after today, you're going to know how to deal with sum and difference of cubes. But here's basically a layout to kind of help guide you with what to be doing. So if you have a binomial that's two terms, these are really the only approaches you can take. You either have GCF, difference of perfect squares, or sum and difference of cubes. So if one of those numbers or variables is cubed, you know you use that method. When you have a trinomial, GCF and then AC method. And then polynomial, GCF, and grouping. So, yeah. All right, so first we're going to talk about U substitution. So, before you go to use U substitution, step one is you want to first factor out any possible GCFs. So do we have a GCF here? And it's 2. So we're going to start by factoring out a 2. So that's going to leave me with 4x cubed, or 4x to the 4th rather, plus 5x squared minus 6. So you're going to get to this stage. Now what you're going to notice is we have x to the 4th degree. What's up?
How did you get to that stage?
I factored out a 2. So at this stage, I'm then going to go ahead and I'm looking at the fact that I have x to the 4th power. Okay? So since I have x to the 4th power, here's what you're going to do when you have this. You're going to replace x to the 4th power with u squared. You're going to replace x squared with u. And you're going to do this every single time that you have x to the 4th, and then you have x squared when you're trying to factor this way. Yes?
So x squared is equal to u.
To u, and x to the 4th, of course, is equal to u squared, which makes sense because, yeah, exactly. All right, so you're going to get to this stage, and what you're going to notice at this stage is you're going to notice, guys, can we not be listening to stuff during the notes? That's how you really are going to be lost. All right. So from here, you're going to get to a point where you can now factor this like any other normal trinomial. Okay? So if I gave you just what's inside the parentheses, you would factor using AC method, right? Remember AC method? So AC method, you're going to multiply here. You're going to get u squared plus 5u minus 24. And then this is going to factor into two binomials. So you're looking for, of course, factors of negative 24 that add up to 5. So any ideas for numbers that would, yes?
8 and negative 3.
Good, positive 8 and negative 3. Once you get to this point, do you remember what the next step is with the AC method? Divide by what you multiplied by, very good, which is 4. And if it divides, you divide it. If it doesn't, you reduce and then move. This doesn't need to be reduced, so I just move the 4 back out front. Okay. So for anybody here who's like, I don't remember how to use AC method, all that stuff, we do have videos on all of that already, as you've already learned it, so please feel free to reference any of those items at any time. All right, so you get here, but here's the problem. Is our original question with u's in it?
No.
So you need to go back and replace. So earlier we learned that we can always make u squared and x to the 4th and vice versa, but you can also make u equal to x squared. So what can I do to get x back here? I can replace it with x squared. So that's just a replacement rule, a substitution rule that you can use. And now you have factored this as much as it can be factored, so you can just circle it.
What's the point? Who just said that?
Of what?
When you
Because we aren't able to factor x to the 4th, so we have to make it into something squared. So it's a method to help us get the degree down. Yep.
you brought it down already just u equals x squared. Like,
Let's go ahead and proceed. So for letter B, first thing you're going to do is you're going to look for a GCF. Do we have a GCF?
No.
No. So you're going to just jump right into switching these into u's. So we know that we can make x to the fourth u squared, and we can make x squared u. And now we're at the point where we can factor this. So of course, we have an a term that isn't 1, so we're going to go ahead and factor it. So I'm going to multiply here. I'm going to get u squared minus 8u plus 12. And then I'm just going to factor. So what are some factors of 12, positive 12, that add up to negative 8? Good, negative 6, negative 2. And then we're going to divide by 4. Can you bring the 4 right over right now? No, you need to first do what? Simplify or reduce my fractions. These reduce to 3 halves. And what is this one over here reduced to? Then what do you do with those denominators? Bring them back in the front. So you end up with 2u minus 3 and 2u minus 1. And then what's our final thing we need to do? Yeah, we got to replace u with x squared. So just to make sure you understand, the whole purpose of using the u substitution is because we can't factor something with x to the fourth, so we have to make it into something that's just squared. So we use what's called u substitution. And you'll see this throughout all your math career so far, your calc. You'll see this a lot in calculus. If you do ever go on to take calc 1, 2, 3, you're going to use u substitution in there as well. So I wanted to make sure we have an introduction to it early on.
See, that makes sense once I learn how to factor.
Yeah, good. All right. So here's another way in which you sometimes will have to use u substitution. So once again, we're dealing with an x to the fourth. We know from earlier we can replace x to the fourth with u squared. So now we have something that's just second degree, so it's a lot easier to deal with. So this is what we call the difference of perfect squares. So how do I indicate that this is what I need to do? How can I figure it out? Here's the way that you know this is the method you need to use. So you're going to end up with two things that are separated, two terms that are separated by subtraction, okay? And they're both perfect squares, meaning you could take the square root of each of those items, okay? So here's what you do when that's the case. I know you've seen it before, but just to refresh your memory, you're going to write two sets of parentheses. One of those is going to be a plus, and one of them is going to be a minus. Now you're going to take the square root of each of those individual terms. What would be the square root of 16? What is the square root of u squared? U. So that would be 4u. And then the second part, of course, is dealing with the second term. What would be the square root of 49? 7. And then finally, of course, we can't leave it as u. We have to replace u with x squared. So we get here. And what you want to just verify is we don't have another difference of squares. Yeah. What part?
U, because the substitution.
I know, but like, why do you write for you if they
The square what?
says it's for you?
Isn't it the square root?
Oh.
Isn't that the square root of 16?
Oh yes, the square root of 16 u squared.
I got you.
Okay. So like I was saying, because I want to make sure you just understand this step, we happen to be finished with this problem, and I want to explain really important why. Sometimes you have to go and factor again, but here's how you can tell. One of these is going to be a plus. That one you don't have to worry about. It's the minus one you have to worry about. You want to make sure that this doesn't factor again. Now, 4x squared is a perfect square, but what's the problem with this term right here? It's not. So for that reason, it doesn't factor any further. If they were both perfect squares, you would factor it again. And we're going to see an example of that in the next one. All right. So let's go ahead and look at D. So D, step 1 is there a GCF? No. Next step is you're going to replace x to the fourth with u squared. Then it's difference of perfect squares, because they're both perfect squares. So you're going to write two binomials. One with a plus, one with a minus. Every single time. It's the same procedure. And we actually I did a proof for why it works in the last lesson that we originally learned this in, if you do want to know why it works. So, what is the square root of u squared? And what is the square root of 625? 25.
How do you know that? How does that make sense? Is that
Yeah. So then from here, we learned earlier that we can replace u with what? X squared. So, when I get to this point, you're going to notice that this is actually not fully factored because of this right here. What do you notice that is again? It's another, yeah, there's another set of difference of squares. So you actually are going to have to go ahead and factor this again using the same method, okay? So, all right, so I got a lot of questions, a lot of discussion, so let me just clarify it, and then if you still have a question, let me know. But the reason that we don't deal with the addition is because it only works with difference of squares. So it has to be strictly subtraction. Addition, technically, if you were to like set that equal to 0 and solve, you'd get x squared equals negative 25, which we know that you can't have a negative square root, so that's actually imaginary roots. So that's the reason that it doesn't factor. And then, Jack, you had a question?
It was addition.
Perfect, okay. So then from here, what you're going to do, it's difference of squares, so you're going to take the square root of each of those. What is the square root of x squared? And what is the square root of 25? 5. So now there's nothing left to simplify, so this is our final answer. Next one we're going to deal with is going to be sum or difference of cubes. So let me explain to you a little bit about the formula. There's actually a typo on your notes, so here's where the typo is. Your difference of cubes formula is incorrect, so you're going to need to adjust it. You got to change the sign here, here, and here, okay? So go ahead and change those signs. You're going to notice your formula is wrong on the paper. What?
Ours is different. Mine was not factored.
So we have to change it to that?
Yeah, it should look like mine.
Minus plus.
I'm saying change all those signs so it looks like mine. You get what I'm saying now?
So you're saying yours is wrong?
No, no. You guys accidentally got sum of cubes formula twice instead of the sum of cubes and the difference of cubes. Okay. So here's how you use this formula. You guys ready?
Yes, ma'am.
So, step 1. First thing you want to do is you want to identify when I need to use this formula. So here's the way to tell. You're going to have a variable to the third power, first and foremost. Okay? Next is you're going to have two terms. If you have a variable to the third power and two terms, this is when this formula comes into play. So here's how you use the formula. You identify if it's going to be sum or difference of cubes, and that's based on the sign between the two terms, which of course this is addition, so it's sum of cubes. Then you're going to basically take the cube root of each of these terms. So, what would be the cube root of x cubed? X. So that's going to be your a. The cube root of the first term is going to be called a. What would be the cube root of 64? 4. That's going to be your b. So now from here, you're just going to plug right into this formula. Okay, that's the formula I'm using, so this is where everything is coming from. It's going to be a minus b, which is x minus 4, times a squared, which is x squared, which is x squared, plus a times b, which is 4 times x, which is 4x. Finally, plus b squared, which is 16. Yes?
Shouldn't the first one be a plus? Like the sum?
Oh, I used difference of squares. I'm really sorry. The signs are all off. Yeah, sorry, I messed up the signs. So, yeah. So the main thing you need to know for future reference whenever you're using this formula is when it's addition, it's going to be plus, minus, plus, okay? When it's subtraction, it's going to be minus, plus, plus, okay? So that's the kind of way you can remember it, but that's just based on the formula. So sorry, I accidentally used difference. I meant to use sum. So does anybody have any questions about how I got this? Please raise your hand. Yeah.
So cube is minus plus plus?
Just like it is up here on the top, you see? Minus plus plus.
Oh.
Minus plus plus. Yep. So does anybody have any questions about how I got any of the numbers of the terms? Yes.
How did you get the a equals x cubed?
So the a is always going to be so the a is always going to be the cube root of this term. So the cube root of something is what you can multiply that by 3 times. You can multiply it by itself 3 times, and that gives you that thing. So, of course, the cube root of x cubed is x, because x times x times x is x cubed. The cube root of whatever this is going to be your b. Okay? So it's just the cube root. And if you don't...
As in 3.
Cube root is the third root, yeah. All right. Next one. So step 1 on this question is you need to start by factoring out a GCF. So it's going to become 2, and then it's going to be x cubed minus 1. So this 2 is just going to follow us down. The whole problem is going to be on the outside. Okay. So your a is going to be whatever the cube root of that first term is. So what is the cube root of x? I mean x squared. I mean x cubed. I'm sorry. And then what is the cube root of 1? 1, because 1 times 1 times 1 is still 1, right? So this is your a and your b. And then is this difference of cubes or sum of cubes? Difference. So the difference formula, the 2 just comes down. It's going to be a minus b times squared, which is x squared, plus a times b, which is x, and then b squared, which is 1. That's your final answer. Now, some of you might be wondering, well, couldn't we factor this more because it's trinomial? Now, just to save you the time and effort, every single time that you do sum or difference of cubes, that resulting trinomial is never factorable. Okay? It's never factorable. There's no factors of 1 that add up to 1 and whatnot. So, yeah. All right. Moving on. Let's do letter C together. So step 1 is what? Factor out a GCF. All right. Step 2 is to identify a and b. What's the a? What's the b? 2. Because 2 times 2 times 2 is 8. The 3 comes down, and it's minus, so it's going to be a minus b times a squared minus a times b, which is 2x. Wait, it's plus, sorry. Plus b squared, which is 4. And that will be your final answer. So what I want all of you to do right now is to go ahead and try D on your own. So everybody should be trying B right now. Yes.